Okay, so if we're gonna keep trucking here, we go back up to our picture up here. Um, Off of Java, we got this thing called C sharp. Actually, what might make decent sense right now, since we were just talking about Android versus iOS, why don't we talk about the Microsoft versus Apple thing leading into C sharp? I think that might be reasonable. So Apple versus Microsoft. All right, so Apple and Microsoft, not friends, right? These guys are kind of were enemies with each other for a long time. But in the early days, so let's call it the late 80s, early 90s, even mid 80s, Apple and Microsoft were both young companies. So I'm just going to create a slide here. Let's kind of talk about them from two different angles. So let's look at Microsoft as well. I'm going to look at Microsoft first. So what did Microsoft revolutionize? What did they create in today's world? They created Windows and some different software and stuff like that, but there's some aspect with how they sell software that they kind of invented that's created the world we have today. And it's licensing. Licensing software. So they sell you a key to allow you to access their software. All right. Now, we think of them as being the guys who created Windows. Was that their first operating system, or do they have an operating system before Windows? How many of you heard of DOS? MS-DOS, Microsoft DOS. Okay. Now, so an interesting thing. So this is in the 80s when personal computers were just starting to become a thing. Before that, computers existed, but they were like, in companies and gymnasiums and stuff like that. They weren't really sitting on people's desks. Well, so Microsoft, how many of you have heard of a company called IBM? Yeah. All right, so IBM back in the 80s was the cool kid in technology. All right, they were, if it had computers, if it had something to do with computers, IBM was the king. All right. So IBM is thinking about getting into PCs in the 80s. All right, but now up to this point, PCs, personal computers that would sit on somebody's desk at home. Up to this point, IBM was already the king of business computing, business machines. So that was already their bread and butter. But now that personal computers were kind of a thing, we didn't know if they were going to take off yet. So it's almost like the early days of the iPhone. It's like, is this going to be a gimmick? Or our personal computer is going to actually turn into something that everybody's going to have? That was a toss-up. So in the early days, they decided, we're going to get into this personal computer thing since everybody else seems to be doing it, but they wanted to keep their risk low. You've heard of Bill Gates? Who's Bill Gates? Are you serious? You've never heard of Bill Gates? I've had people who didn't. All right, Bill Gates, guy, founder of Microsoft, right? So this is Microsoft guy, founder of Microsoft, and proverbial super rich person. I think right now he's like 2 or 3 in the world, but richest. But he's like $68 billion or something. I think the Amazon guy is number 1 right now. Just a little bit, but he spent a while up there. All right, so in any case, he's the founder of Microsoft. And he one time had a meeting with IBM. And I don't know if this is exactly true, but I would suspect it's at least in the realm of possible. This might have been the most profitable meeting in the history of meetings. So he's sitting across the table from Microsoft, him and a couple other people, or sitting across the table from IBM, him and a couple other people from Microsoft. And this is when IBM is considering getting into the PC market. And he says, look, we want to license. We don't want to sell you our software. We want to license you our software on a per machine basis. So every time you sell an IBM computer, a personal computer that comes with DOS on it, well, we didn't name it, just their software, we get a commission. We get a licensing fee. Make sense? So they only get paid if IBM sells a computer. That's like a good deal for IBM? Yeah, IBM's not taking any risk. Famous quote from IBM. No problem. The real money is in the hardware. Sounds kind of funny now. Go ahead.
No, IBM company is just selling the hardware.
Yeah, but they also had proprietary software that ran on business things. Now they're getting into, but forget about the business side of it. Now this is normal people running computers at their houses. So all the software that IBM had up to this point was software that they kind of created for businesses, mainframe software, COBOL, yeah, things like that. Yeah, this is consumer stuff.
So they can get software. So why do
they were not a software company. They would get software someplace else. And this personal computer market was something they were just debating getting into. They didn't want to throw a whole lot of money at this. It's like, look, we already have the manufacturing infrastructure to build the computers. Now, if we have your software we can throw on it that's software for personal computers, and we only have to pay you if we sell a computer, maybe it's worth trying. Make sense? So IBM said, no problem, the real money's in the hardware, which it's kind of funny when you think about it historically, because far more money's been made off of software than it's been off of hardware, because hardware you make it once, then you have to make it again, and you have to make it again, and you have to make it again if you want to sell several of them. Where software, you make it once, and you just duplicate it instantly and just sell it over and over and over and over, and it's way more profitable. All right, so Bill Gates, IBM, they make a deal. Bill Gates has this vision that we're going to license software because he thinks that's what's going to be really good for Microsoft. And IBM, because he thinks personal computers is going to be a big deal. And IBM thinks that they're getting a good deal because they're used to making their money off of hardware. So that's where the real money is for them. There's one little issue here. Anybody know what the funny issue related to this deal was? Microsoft did not have an operating system. So Bill Gates walked into this meeting with IBM and agreed to license their operating system to IBM on a per computer basis. He made an agreement with IBM for something he did not have. He didn't have software. He didn't have an operating system. Yet he had just promised IBM that they could use his software on a per machine basis when they released their personal computers. So now Bill Gates has to go and figure out where to find an operating system. So the funny thing is Microsoft did not have an OS. Now they need to find one since they just sold it to IBM. So they actually found, this is kind of like a Radio Shack type place they went into. The rumor was there was this guy who had written a small operating system like as a hobby, just for fun. And Bill Gates went in there and offered him $50,000 for his operating system. So if you're some guy running a little tiny computer shop in the early 80s, and somebody off the street comes in and offers you 50 grand for the piece of software you've been writing in your spare time, you say yes, right? So Microsoft got DOS for 50 grand. I think that was a pretty profitable purchase for them. They did all right off that deal. All right, so that's kind of the funny backstory is, Microsoft made that deal by selling a piece of software they didn't have, and then went and found the software. It's kind of an interesting backstory. That's kind of the art of the deal type thing, right?
Only operating system that they want to sell, or they will sell more than one kind of software.
Well, eventually, but this is early days where using a computer was all about the operating system. I mean, we didn't even have mice. There was no mice to double click on things and stuff like that. This is all text based. People programmed their own computers. They would go and buy a book that showed them how, gave them all the code to write their own software, write their own video game to play something. It was very, very early days of personal computers. All right, so blah, blah, blah. Microsoft now has DOS and is licensing it to IBM. Now, we throw Apple in here. So Apple, we've all heard of the company Apple. So when they first were making computers, they had a line of computers called the Apple. Well, they had the Apple I, the Apple II. So Apple computers ran DOS. So that means they had a partnership with Microsoft as well. So if we just do a quick search here, if you've never seen one, so if we do Apple II, Apple IIe would be fine. That'll show us what it looks like. So this is what an Apple II computer looked like. Crappy monitor, blah, blah, blah. And here's the original Apples. These are the kits that you could buy to make your own computer at home. And these sell for like thousands and thousands and thousands of dollars now on eBay. People have big auctions for them and stuff like that. Because you were making your own homemade computer. So this was the original Apple kit that people would buy. Here's Wozniak with it. All right, so a little different than our computers we think about today, right? So if you think about where Apple started, it started there. Then when they got to the Apple II, now it looks more like a computer because they built it for you. It's no longer a kit. All right. These computers were running DOS. The Apple IIs were running DOS, Microsoft's operating system. All right. So Apple computers ran DOS. Now we've heard of Steve Jobs, the Apple guy. Okay. Now, what about Macintosh? When you think about Apple computers today, you think about Macs, right? You're going to buy a Mac. You can't go to the Apple store and buy an Apple computer. You buy a Macintosh computer. Internally at Apple, they had two competing lines. So you had the Apple line and you had the Macintosh line. Apple was DOS-based text interface, so old school. Macintosh was new OS based, so Mac OS based mouse / GUI. All right. How many of you have heard of a company called Xerox? All right, what does Xerox do? Printers, copy machines, those types of things. All right, so this is back in the early days of personal computers. Xerox was working on an internal machine called the Xerox Star. That was its code name. And they had created kind of the first graphic user interface-based operating system for this. And then all of a sudden they decided, so this is in that time where we weren't sure whether personal computers were going to take off. Not a whole lot of people had them. Like now everybody has a computer. But back then, they didn't. And so there was some internal debate, and the people at Xerox finally scrapped the idea, and they said, you know what? The real money is in printers and copy machines. Now they've done okay with printers and copy machines, right? Xerox has done all right for themselves. But they had what became the future of all of our operating systems. They invited Apple in and just turned it all over to them. So Mac OS, the Mac OS that came out with the Macintosh was based on the Xerox Star OS. Came with a key, came with a mouse, all that stuff. All right, so this was really our first personal computer that had a graphical user interface that people were could use with a mouse. That was the whole new thing. Now, what was interesting, and you can actually find this video on YouTube somewhere, of Steve Jobs giving the keynote for the first Macintosh computer, with the graphical user interface and everything like that. And about halfway through it, you can kind of tell he gets like a message to somebody in his earpiece. Notification came in that machines were being shipped in China. I think it was China that were running Microsoft Windows. So this is where that war started. So Microsoft was already a partner with Apple because they were providing the operating system for the Apple computers. They were providing DOS. Apple acquired the Xerox Star OS and started working on their Macintosh side. Somehow, Microsoft stole that, or copied it or something. They did something and effectively started shipping their own graphic user interface-based computers at the same time. Right? Kind of stealing some of Apple's thunder. Did not make Steve Jobs happy, right? So that's where they became enemies, right? Because Apple computers went away, right? The Apple brand of computer, they're all Macintoshes now. So no longer did Apple need Microsoft to give the operating systems for their Apple computers. So you had that breakup. Yeah.
Exactly the GUI that makes them Steve Jobs maybe might say they stole our idea of making GUI.
I mean, he would have said something along those lines, even though they got their idea from Xerox Star. So Xerox gave the idea to Apple. Then Microsoft, we could say, stole the idea from Apple. Now they both have graphic user interface-based operating systems. So, I'm not sure we have enough information about what actually happened behind the scenes, but punchline is they both came out with competing products the same day, and something didn't smell right, is the idea. Now, Steve Jobs, he wanted to focus on the Macintosh product. All right, and this is now he's at war with Microsoft, right? He's not happy because now he's got a real competitor. Macintosh product did not do well early on. So internally at Apple, you still had an Apple product and you had a Macintosh product. And Steve Jobs wanted to focus on Macintosh. So he kind of stepped down as CEO and inserted himself into the Macintosh team. He hired, and the guy's name's escaping right now, but he hired the CEO from Pepsi to be CEO at Apple. Famous quote there is, "Do you want to change the world or sell sugar water the rest of your life?" That's what Steve Jobs said to him to get him to come join Apple. All right, now Steve Jobs is he's passed away now, but when he was alive, you could say he was very passionate about what he did, right? Guy was, I think maybe it takes somebody who's that dedicated to something to change the world like some of these guys did. Some of the books that have come out, I'm not sure Steve Jobs was necessarily the best father and things like that because computing was his life. I think maybe to change the world the way some of these guys did, you maybe needed to be bad at some of these other things, to just be so singularly focused that, something had to give. But in any case, Macintosh wasn't doing well. And the Apple board fired Steve Jobs. So he was fired from his own company. How does that happen? How do you get fired from your own company? Apple's a publicly traded company. So Steve Jobs owned lots of shares of Apple, but a publicly traded company is owned by the shareholders and managed by the board of directors. The board of directors voted him out of the company. So he was fired from Apple. Now, what did he do during his time while he was fired from Apple? A couple different things. He had a buddy, the guy who made all the Star Wars movies. What's his name? George Lucas. George Lucas was going through a kind of expensive divorce and needed some cash. So he had a little company you probably never heard of that he wanted to sell called Pixar. Heard of Pixar before? Toy Story, all the other cartoony movies. So he sold Pixar for about $7 million to Steve Jobs. Steve Jobs, years later, sold it for $8 billion to Disney and maintained control of the board. So he actually pretty much still ran Pixar even after he sold it to Disney. That was pretty profitable. That was years and years later. So, he bought Pixar early on. More importantly, even though that sounds like a pretty good deal, he founded a little company called Next Computers. How many of you have heard of Next Computers before? Nobody. Very interesting. It's going to be a very enlightening thing for you. Here's Next Computers. Oh, there's Steve Jobs with Next Computers right there. Recognize that guy? Young Steve Jobs. Well, alive Steve Jobs too, but this is Next Computers. Back at this period of time, not only were, Microsoft and Apple kind of at war, but if you were a Macintosh user, or if you were any kind of Apple user, anything you did was incompatible with a machine running Windows. Okay? They just were not compatible with each other. They used different file systems. They used different everything. So the idea, so we really had this problem in personal computers where it really did matter what kind of computer you bought because you were separating yourself from everybody else who had the other kind of computer. Make sense? So one of his ideas with Next Computers is, this thing's going to be compatible with both. And it actually was a pretty good idea, but it was very, very expensive. It really only became a popular thing in some universities. They were powerful machines. He spent a lot of money on this logo, and then he spent a lot of money on a manufacturing plant that made like high quality stuff. And we kind of see that in Apple even today, like when they announced the Apple Watch, and they were kind of talking about how they like reinvented the metals, right? Like it's not just normal gold. This is a gold that we mixed with soybeans, and it's something special. It's some better kind of thing. So Apple's all about the way they engineered things for years and years, and it kind of started with this. But in any case, he created Next Computers and never really took off. Now, when he died, he was the CEO of Apple, right? Well, actually, when he actually died, he had already given up being CEO, but he was still head of Apple. How did he go back to Apple? Did Apple rehire him? What does proprietary mean? When I say that Apple is a proprietary company, what am I talking about? It's kind of the opposite of open source. So we mentioned earlier, like Android is open source, which means anybody can go in, they can look at the source code for it, they can see everything. Linux is open source. Apple is a proprietary company. They keep everything very private. Okay? Only their stuff works with their stuff. Their software works with their hardware, nothing else. You can't go and install Macintosh operating system even today on a Windows machine without doing some stuff. There's a project called Hackintosh that kind of lets you do it, but it doesn't run real great. So they're considered a proprietary company. Now, to most people, when you hear the word proprietary, that has a negative connotation, right? That doesn't. We think of that in a negative light. Because as good humans, we like the open source community. We think that's good. We should share knowledge with the world, right? Don't you wish Apple did that? So they share knowledge with the world? You know, Apple tried to do this once. You know, Apple hasn't always made the hardware and software. They started off making their own hardware and writing their own software for it. And today, they make their own hardware and they have their own software for it. But there was a period of time in the middle there that they decided, you know what? We're going to go ahead and allow third-party places to make Macintosh clones. So allowed Mac-compatible PCs, Mac clones, which had a lower cost. Because at the same time, when I mention a Mac to you, a couple dollar signs pop up in your head. Apple's considered to be expensive, right? You can get more computer for less money going to a different brand. So Apple, they're built very nice, but they have the same stuff inside of them as, you know, the equivalent machine from HP. It's just, you know, not made of steel and, you know, whatever. The build quality is a little bit less, but money is also less. So they allowed companies to make Mac clones that would run the Mac operating system. And a lot of people started buying Mac clones. And Apple almost failed as a company. When Apple gave up some control, they literally almost failed as a company. They were pretty close to declaring bankruptcy. So what ended up happening is they acquired, well, let's go back here. Well, let's just do it here. Apple acquired Next Computers. I'm missing an R. Oh, a C there. Just had a couple of those. There we go. All right. So Apple acquired Next Computers. It's supposed to be funny. You put a whole bunch of C's like that. So Apple acquired Next Computers, which came with Steve Jobs. So they bought the company that Steve Jobs owned. Now, when I say bought, I use that very loosely because we're really talking about Apple folding as a company here. So really what happened is when he came back, Steve Jobs paid Apple payroll for a while using his own money and a loan. Where do you think that loan came from? Borrowed money from Bill Gates. So, came back to Apple, was put in as the interim CEO. Interim CEO, ICEO. Made some changes at Apple, right? They no longer supported clones. He wanted to control both sides. Came out with a couple of products you maybe have heard of. Came out with an iPod. Fairly successful. So revolutionized music, right? The way people listen to music. Came out with the iMac. All-in-one computer. Became very popular. Came out with something called the iBook, which was a laptop that actually never really took off. But it was cool for 5 minutes. They did look cute. Here's the iBook. This clamshell looking thing. It's the iBook. Came out with the iPhone, also mildly popular. I think something like 70% of all Apple's profits now comes from iPhone. Came out with the iPad. And came out with Mac OS X. All right, so now I'm going to tell you a secret. You're not going to tell anybody, right? This is a secret. So let's go and look at some of the programming documentation for Apple. This is current. So if you're writing some stuff for iPhone or something like that, we have a whole bunch of objects in here, and one of them is a class called NSString. And you'll notice that we have a lot of classes that start with NS in Mac programming. NS stands for next step, as in next computers. Apple died. What we have today is next computers with an Apple logo on them. How many of you knew that? Pretty interesting. Kind of gives you chills that this company that a few minutes ago we mentioned didn't do well. Next computers never really took off. Is Apple today. Just with a better logo. Which is really ironic given how much people used to complain how much Steve Jobs paid for that next logo. You paid some ridiculous amount of money for that. I don't remember the number, but way too much money for that logo. It just to have somebody make it. I don't know the whole backstory with it, but there was a storyline around just how anal he was about that logo and paid like way too much for it. And then the funny thing is that the only thing left from that company now, or the only thing not left from that company now, is the Apple logo. It's the only thing that didn't come with them. Everything else is from Next Computers. So, yeah, kind of a interesting backstory there. And then obviously, so, with this came a new partnership with Microsoft. Now, realistically, do you think Steve Jobs and Bill Gates were ever like buddies? There was some history there, right? But these guys were a little older, a little wiser, had already gone through some stuff, and maybe kind of realized that they needed each other. Do you think that's maybe why Microsoft lent Apple some money? Do you think that's why Steve Jobs recreated a partnership with Microsoft? Now, some people might say, well, Microsoft, they lent Apple money because, you need competition. Was Apple really a strong competition for Microsoft? I mean, 5 minutes ago, you have a company that's failing, right? Apple is falling apart. They're barely solvent. And, Microsoft is just figuring out how to spend all their money. There was no competition. Microsoft had, let's call it 97% of the operating system market. Solid. But we're missing 3%. We're missing 3%. Okay. Now remember, we had that issue about compatibility we talked about a little bit ago, right? So the people that were running Linux, so the people that were running the Mac OS, they might not be using Microsoft products. Therefore, the files, were not compatible with stuff on the Windows machine. Maybe Microsoft saw an opportunity. Maybe they thought, you know what? Maybe we can write if they're not going to run our operating system, maybe they'll run some of our other stuff on the Mac. And we can make money off them anyways. Microsoft Office is available for the Mac today, right? And if you save a file on the Mac using Microsoft Office, it's going to save as a .docx. Open it up on Windows, it'll open just fine. Before that, you had like Corel Word, and just all sorts of different crazy formatted things. I know some students will sometimes use so like Apple's word processor is the thing called Pages, right? Which is convenient if you're completely in the Apple ecosystem. Pages is nice and convenient, but if you turn in a paper to a teacher in .pages format, unless they're a Mac user, they won't be able to open it. So usually you would export it as a PDF or export it as a .doc from Pages if you use that, or you just install Microsoft Office on your Mac and write everything in Microsoft Office. So I think Microsoft, and I'm not positive on this note, but I think Microsoft saw an opportunity where Apple sticking around wasn't really a bad thing for them. Because Apple's going to sell computers to people, and maybe, Bill Gates assumed that, hey, they're probably going to rebound here and start bringing some people back, and they did. If you listen to the Apple fanboys, they would say that, oh, well, that half the people are running running Mac OS, and the other half are running Windows, right? No. What do you think the divide is today? I mean, how many people in here have an Apple computer? A couple people. I have one. We have 3 other people have an Apple computer. So does that mean that that Mac OS is installed on 30% of the machines in the world? And the other 70% are running Windows? What percent of desktop computers or laptop computers do you think are running Windows right now? You think 50? You think 80%? 96? That might be a little high, but I think we're close. Yeah, I mean, Microsoft's lost some of its shine. It probably doesn't hold 97% of the market anymore. Maybe it's 94. It's high. It's very high. Microsoft is not losing the desktop dominance market anytime soon. What's happening is desktop's moving away. Before long, these are going to be our computers. And the popular operating systems today are Android and iOS. Microsoft is barely a player in mobile. Okay? So what becomes interesting is many people have Apple laptops. Apple laptops have become very popular, especially among young people. So you have more people who are running the Mac OS because of that now, but nowhere near like competing with Microsoft Windows. You're not at that level. Windows is by far the most popular. So really, the Macintosh folks have very little leverage, which kind of becomes interesting, and that pulls us back over here to our Java discussion. Java is known to be something called platform independent. How many of you have heard that before? What does it mean for Java to be platform independent? So the idea is write once, run anywhere. Write once, run anywhere. Now, there's a little catch to that. Historically, if let's say because you had an issue before this, so this really comes from let's put it in quotes, the issue that some software would come out for Windows and either never or take a long time to come out for the Mac. And really, probably the loudest screamers were the gamers. So if you played video games, and the game you really wanted to play came out for Windows, but your family had a Mac, you couldn't play the game. It wasn't available. Back then, there was even more incompatibility between Macs and PCs. Because back then, PCs were running on Intel processors. Macs were running on PowerPC processors. They were a whole different architecture. Now, everybody's on Intel, or AMD if you want to go budget pleaser, which is Intel compatible. So let's just call it Intel. That's something else that Steve Jobs brought to the world. If we just go back there. Switch to Intel. You know what? This was a really big deal and a really big risk. That could have really hurt Apple when they made that switch, because Mac OS X was already out. And the original Mac OS X was written for PowerPC. Now, the issue here is that, so Mac OS X comes out. Well, actually, we got to go a couple of routes here. It's like a double whammy. Mac OS X was not compatible with Mac OS 9, which was their latest operating system before that. So Mac OS 9, OS 8, OS 7, all those were just upgrades to each other. So software that was installed in Mac OS 7 would still run in Mac OS 8, would still run in Mac OS 9. But when you jump to Mac OS X, now it's a Unix-based operating system, because it's the system that came with Next computers. Make sense? So if you had software XYZ for Mac OS 9, it would not run on Mac OS X day one. So what ended up happening is you had people who went out and upgraded to Mac OS X and then had to install a little program called the Blue Box. Anybody heard of the Blue Box before? How many of you have heard of like VMware or Parallels, so virtual machines, right? That allow you to run another operating system within your operating system. You could host an operating system. Blue Box was kind of one of the first ones, like certainly one of the professional ones of this. So what ended up happening is when you bought Mac OS X, it came with a program called Blue Box, which allowed you to launch OS 9 within OS X so you could run your old software, which made your computer slower. So you got this nice computer with a brand new operating system that you can't use for almost anything. Instead, you have to emulate your old software, your old operating system, to run any of your programs, because a lot of the companies hadn't ported the programs from OS 9 to OS X yet. So they were not compatible with each other. That was a major jump to go from OS 9 to OS X. It's a risk that paid off. Now, what's funny is, so eventually the software caught up, right? Most of the software you used to use in OS 9, you can now get it on OS X, assuming you were willing to pay for it again. Everybody wants money, right? But then Apple made another decision. They switched to Intel. So now all that software that you currently have that now works on OS X for PowerPC processors will not work for OS X for Intel. Because when you bought your next Mac, you now have a computer that is made by the same company, but at the hardware level, they're not compatible. That make sense? Now, I'll throw another little backstory thing in there. So if we kind of let me just do it after this guy. So we had these chips called PowerPC, which surprisingly were made by IBM. And IBM had problems keeping up with them. So you had the PowerPC G3 processor. You had the PowerPC G4 processor. So here, if you want to see the lineage of this, we'll just do Mac G4. So this is what those guys look like. So this was a Mac Pro with a G4 processor in it. This is what it looked like. All right. Now, let's see if I can actually find... this would be worth watching if they... Yeah, so here's one of Apple's early things for the G4 processor.
For the first time in history, a personal computer has been classified as a weapon by the U.S. government. With the power to perform over 1 billion calculations per second, the Pentagon wants to ensure that the new Power Macintosh G4 does not fall into the wrong hands. As for Pentium PCs, well, they're harmless.
So Pentium PCs were Intel based PCs. Let's go back here. So the G4 was supposedly the first supercomputer, that you could do 1 teraflop of instructions per second, which just sounded cool. But these guys were all PowerPC. And then right before the end of PowerPC, so during this age, these guys are still running Mac OS 9. Okay. Then Apple came out with dual CPU GeForce at the same price point as the single CPU G4. So now you can get, and I timed this perfectly. I didn't know they were coming out with a dual. I had a G4, and I sold it on eBay. This is like when eBay was really young. I sold it on eBay about a week before they announced the dual processor GeForce. So I basically got a dual processor G4 for like an extra like $80 from what I sold my single one for. It was good timing. But the funny thing is it didn't even matter because of this next punchline. So they came out with dual CPU GeForce. And let's see if we can find the Mac dual G4 commercial. Thinking that's not. Yeah, that's what I saw. Thinking that's not it. Well, in any case, they had the whole commercial was about two heads is better than one, 2 brains is better than one, because now you have 2 processors, 2 supercomputers inside of 1 computer. But the irony here is that Mac OS 9 did not support 2 processors. So you got this brand new computer that was not actually, whose hardware was not actually being fully utilized by the operating system. So only if you had like a program like Photoshop or something like that, which specifically took advantage of a second processor, were you getting benefit from that second processor. Pretty interesting. So there was a time period where Apple was selling hardware, running its own software that didn't take advantage of its own hardware.
People didn't know about it.
I think most consumers didn't. Most techies probably knew. Mac OS X, though, did support because it was based on Unix, so it supported multiple processors, no problem. All right, so kind of going back here, when we switch to Intel, now all of a sudden you have a whole bunch of people that are running Mac OS X and have software, so pretty much Blue Box is dead at this point. Nobody's having to run Mac OS 9 to run some of their old software. It's really, really rare. Most software has been ported over to Mac OS X. Now all of a sudden Apple says, by the way, we're switching to Intel. So all you people that ported your software to Mac OS X for PowerPC, now you need to port it to Mac OS X for Intel. Not as bad of a port, but still took some time and resources. And at the same time, you had people who had already invested a lot of money. Let's say just that year, let's say you had bought the latest, greatest G5 PowerPC machine running the latest, greatest OS X for PowerPC. And all of a sudden, Apple comes out with an Intel-based machine. And that's the new future. Yeah, you just dropped $3,000 on a machine that is fine for now, probably. But a year and a half from now, they're not going to have any new software for it. Nobody's writing stuff for PowerPC anymore. They're writing it for Intel. All timing, right? They switched to Intel. Really, really, really big deal. This gave them faster performance. This put them more in an even playing field with software makers, because now they didn't have to write for two different complete architectures. They just had to target two different operating systems. Maybe wasn't the end of the world. That type of thing. So really, when Steve Jobs came back, he did a lot. And he surrounded himself with good people, so we don't want to say he had all the ideas. I'm sure he had plenty of people who had great ideas that he just went along with. So he probably gets more credit than maybe he completely deserves, but whatever. But understand, when we go back here, when we talk about Java being platform independent, this whole write once, run anywhere idea was something that was pretty strongly fostered by the folks who were Macintosh users, who said, oh, well, software XYZ runs on their machine but doesn't run on my machine. And even among Apple users now you have that problem, because they're running OS 9 versus OS X, or they're running PowerPC machines versus Intel machines. So now you have an issue with not all Macs are compatible with each other. And none of the Macs are compatible with the Windows side of things. It just became kind of a very interesting, this was a very interesting transitional period from Apple that, I mean, that could have gone either way. It's very, to be honest, when you look at the number of things that had to go right for Apple in order for them to come out the other side of that, pretty interesting. And if you go back to this list, it really was probably that guy. The iPod held Apple up through those changes. You know, and once they went iPhone, those changes had already been in the past. So you could say iPhones really helped them a lot recently as well, probably more than iPod did money-wise. But at the time, iPod probably allowed them to survive those changes that really did need to happen, but they probably would not have survived if they just were a computing company that didn't have these other businesses and just said, we're switching. Yeah.
But I think they didn't survive, because as you say,
All this came after Steve Jobs came back. All this, I mean, everything that's on here is post Steve Jobs coming back. Yeah, so before that, OS 9 was the latest operating system. So on. Actually, I think OS 8 was the operating system when Steve Jobs came back. So they released another update to OS 8 with OS 9 while he was at the helm. I'm pretty sure that's accurate. Yeah, so he didn't just immediately come back and drop OS X on him. That was something that came like 2 years later or something like that. You know, but that was in the works of getting that stuff over. But the popularity of the iPod, I think, allowed them to survive. I mean, those are drastic changes, because at that point, you're alienating your own customers. Apple had made a whole business out of, you know, making their customers hate the other guy, right? Like, oh, we don't like Microsoft, just cuz. But now, all of a sudden, you have their own customers not liking other people because of which version of the Mac they had. They had the Intel version, somebody else had the PowerPC version, and everything in the future is going to be Intel. Your PowerPC version is useless. They go onto eBay and try to buy an old Mac G4. They probably sell for nothing, because they can only run like the first 1 or 2 versions of Mac OS X. Everything since then has been Intel. So that's really where this idea of platform independence came from. Is that, okay, we got a lot of changes happening in computing anyways, certainly within Apple. But at the same time, we for a long time have had this incompatibility between Windows and Mac. And if you start writing software using a programming language like Java, which will run on both, that's great, right? But how does Java accomplish this? It accomplishes it through something called the Java Virtual Machine, JVM. How many of you have heard of that before? What is that? What is the Java Virtual Machine? It's a lot of things we've heard of that we don't necessarily know what they do, right? Anybody know what the Java Virtual Machine is? That's not entirely incorrect. It's not what's actually happening under the hood, but the end result is something along those lines. What the JVM is it's a Java-based computer written in software. So when you run a Java program, no matter what kind of computer you're running it on, you're running it on the Java Virtual Machine. Okay? So the Java Virtual Machine is kind of like Blue Box or kind of like VMware, except the operating system it runs is Java. It knows how to run Java programs. So Sun Microsystems were the makers of Java. And what their idea here was, it was this. They said, you know what? It would be a good idea if instead of making all the developers spend a lot of time porting software from Mac to Windows or Windows to Mac, whatever it is, Sun ported the JVM to Mac, Windows, Linux, Unix, popular OSs. So they spent the time to port the virtual machine to all those different operating systems. So, and each of those virtual machines, even though they were functionally equivalent, but one might have been a little bit faster for certain things than other ones because it was happened to be implemented in terms of the underlying operating system. So now that you have the JVM on all these different operating systems, you could write your Java program and it would run on any machine that supported the JVM. That makes sense? That's how it accomplished platform independence. You write it once in Java, you compile it in Java, which takes you down to a .class file, is what gets created. And then the JVM interprets that .class file and runs it on the native operating system under the hood, kind of like turning it into an exe is kind of like what you said. It doesn't actually convert it to an exe, but functionally it kind of does the same thing. But that's how they pull it off. Now, that sounds pretty good, right? Can you think of any downsides to that? Not all software today is written in Java, is it? Must be a downside. It was almost about asking for the wrong thing. Because the people I mentioned earlier, the people that were really screaming about this were the gamers. They were the ones really most upset about software coming out for Windows that wasn't coming out for the Mac. So you might say that the first people that really wanted to take advantage of the Java technology was gamers. Like, oh, we'll start writing video games in Java. For small games, that maybe works out okay. But this is around the same period of time when our computers started getting a lot more powerful. You know, when you buy a computer today, if you're a gamer, you really consider what kind of graphics card you're going to get for that computer. That's an important element to your purchase. Back then, your computer just had a graphics card. That's how it showed stuff on the screen. So as our games got more and more complex, Java can't keep up with that. Because now what you're trying to do is you are running a video game on top of an emulator. So you're running it on top of the Java virtual machine, which is then converting it to native stuff on that machine. So you're going through a translator in order to make your game run. That, at the very least, will slow it down some. right? And we've talked earlier about low-level languages, and the people that might still use a low-level language would be like game makers because they want to make something really, 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 really fast. So if you have even any slowdown over here versus an industry where we're trying to make things super fast, even at the cost of like logic, that probably isn't going to make a lot of sense, right? So never took off for gaming. Java is perfectly acceptable for business applications. But what ended up happening, for the most part, is, like, for instance, Microsoft. Their version of Microsoft Office for the Mac is written natively for the Mac. It's not written in Java to run on the Mac. So they have two different code teams. They have the team that writes Microsoft Office for Windows. They have the team that writes Microsoft Office for Mac. Those are native applications for those two operating systems. They're not relying on Java, which will slow it down, even though that might not be that noticeable on a desktop type application, like a business application like that, where performance isn't as noticeable. Nobody's ever bragging about how many frames per second they get on Microsoft Word. That would be pretty funny, though. That would be like a funny YouTube video. It's like, man, I'm getting 2,700 frames per second on Word. It's like, that doesn't even make sense. In any case, Java really didn't take off there. In fact, there was a reasonable chance that Java was going to actually fail as a language, never really take off. Probably two things kept it afloat. Google was a Java shop. We haven't mentioned, we mentioned Google as it relates to Android, but Google was a little bit late to the game. They weren't there at the beginning of the Apple-Microsoft war, right? Google has not always been around. They started off as a search engine, right? But the early days of the internet, we didn't have Google. We had Gopher. You actually had a protocol in the early days of the internet that was for searching that wasn't even based on web browsers, called Gopher Search. Kind of like a automated, almost like a library system, something like that. So that kind of went away. But then we had, you had 5 or 10 different competitors in the early days for search engines. Popular one was one called Ask Jeeves. Have you ever heard of Ask Jeeves? Ask Jeeves was I wonder if that's still around. Yeah, so here's this. I don't know if that's the same one though, but this is an old search engine. There was another Lycos search engine. Oh, look, these things are still around. Nobody uses these. I'm probably the first one to visit this page in a decade. That's actually really funny. So in any case, you had a bunch of competitors, but Google kind of took over. And really now you only have what? You have Google and you have Bing. Kind of Yahoo has a search engine, but I mean, nobody uses Yahoo for searching now unless it's the default search engine for your browser for some reason, right? You didn't do it on purpose. You might use Bing. Google's probably most people's go-to move. But regardless. So Google used Java internally because Google also did not like Microsoft. So they weren't going to necessarily adopt an internal native language of one of the Microsoft languages. Because Google for a long time was kind of buddies with Apple, right? You had a lot of members of Apple on Google's board and a lot of members of Google on Apple's board for a while. So you still had Microsoft as the enemy, and Google and Apple were friends. Because they weren't competing with each other, right? Google was the king of search, Apple wasn't in search. But then all of a sudden they started playing in similar sandboxes. iOS, Android, that's kind of become a pretty good competition for them now, right? I don't know if it's fair to say that Google hates Apple, but there's certainly a significantly more competition there between them now. But from day one, Google was not a fan of Microsoft. Nobody liked Microsoft. Microsoft is the big monster who has too much money and stuff like that. They just have there's nothing wrong with Microsoft. People don't like them because they were too successful. right? Is what it is. That's the, even today, people try to demonize Microsoft, like, oh, there's Microsoft stealing that again. All these big companies do that. It makes more sense. If you're Microsoft, you'd rather steal something than settle outside a court. They'd have to go through all these negotiations to buy it and not hit market in time or something. It's just how business works. They all have the best people in the world working. Microsoft has the greatest developers in the world, the same guys that Apple has working for them, the same guys Google has working for them, and then they just trade. Right? Somebody leaves one company, they go to the other one. So all these companies are, they have the smartest people in the world working for them. They were just jealous, Microsoft. They were too successful. So punchline is Google was a Java shop. So that kind of kept the language popular. Secondarily, we have something called Java applets. How many of you heard of a Java applet before? Pretty popular thing. It's kind of like the most popular technology that we don't think about. A Java applet is a fully functional Java program that launches from a web browser. So if you think about websites and you think about the level of interactivity you have with websites, today websites are pretty advanced, right? You can have a website that does a whole lot of interactive stuff without ever leaving the web page. But back in the early days of Java, that didn't really happen. And even today, we can tell the difference between a website and an application that's local on our machine, right? There are limitations to what you can put on a website, where you can have an application that's running on your computer that you would know the difference between the two of them. So really, where Java applets were most heavily used, there were some sites that just kind of used them as almost like jokes or whatever. They weren't. They used a Java applet, but they didn't need a Java applet. But there was one industry where applets became very important. Stock trading, i.e., where the money is. If you go to one of these stock investing websites, E-Trade, Ameritrade, whatever, almost every single one of them has like a professional trading platform that you can either pay for $100 a month, or if you keep enough money with them in your account, they give it to you for free. Something like that. These are for people who are like serious day traders, that are trading lots of money every single day and stuff like that. So the professional day trading tools offered by various trading banks are all written as Java applets. That way they don't have to worry about what kind of computer you have. Are you on a Windows machine? Are you on a Linux machine? Or are you on a Mac? They have a Java program that launches out of their web page. And it's your trading platform as a native application running in Java on your computer. I mentioned earlier that business applications are fine in Java, right? Games are when things slow down. Real-time stock trading, Java's fast. It's not like, I don't want you to have this idea that Java is like this snail's pace programming language. It's just not fast enough for video games because the gamers are too demanding. So if you go to like, let's just do E-Trade, professional trading platforms and tools. So it'll probably take us there. Oh, it's going to make me go through that. Well, in any case, they have like a professional trading type tool here. Maybe I can even find an image of it. Yeah, something that looks like this. that would launch out of a web browser. And you would run that on your computer, even multiple screens on your computer to do day trading type stuff. So those are the kind of the two places that really kept Java alive. Because heck, even the company didn't survive, right? How many of you have heard of Sun Microsystems before? Who are they now? They're Oracle now. Yeah. Now, funny, so Sun Microsystems, so if you go, a lot of times, because I've been doing Java for so long, I'll just go to java.sun.com, and you'll see it'll rewrite that to Oracle site. Okay, so Oracle purchased Sun Microsystems. Now, what was funny is on the stock market, you know how each company's stock has like a ticker symbol? Do you know what Sun Microsystems' ticker symbol was? You know, like Microsoft is MSFT, Apple is AAPL. What do you think Sun Microsystems was? Yeah, it might make sense to be like Sun, or it was Java. Their ticker was Java. Problem was they never figured out how to make money off Java. Almost did. Almost did. And what do I mean by that? Talked about C# versus Java. How many of you have ever heard of something called J++? How many of you have heard of Visual Studio? What's Visual Studio? It's Microsoft's programming tool. So if you're going to write software using one of Microsoft's core languages, you use Visual Studio. It's their super editor. You mentioned IDE, Integrated Development Environment. So it's their thing to make life as a programmer easier. And they introduced the language. So this is Microsoft Visual Studio. See how all these things are interconnected? So this is Microsoft Visual Studio. And in Visual Studio 6.0, I think that was the version it came out as, they released a language called J++, which was Java syntax in Visual Studio IDE. So there was a lot of people that really liked Visual Studio as a development tool, because up to that point, Visual Studio you would do either Visual C++, Visual Basic. Really, those were probably the two languages you would use. This is before C#, didn't exist yet. All right. They also had a tool called ASP that you could do with that. This is before ASP.NET. This is before .NET. .NET wasn't a thing yet. So they released another language called J++, because all of a sudden you had all these people that were really, they liked Java. Okay, but Visual Studio allowed you to create graphical user interface applications with like drag and drop type stuff. So now all of a sudden it's like, and that's not as friendly to do if you just want to use Java directly. They have a library called Swing. In the early days, it was called AWT, Abstract Windowing Toolkit. And it wasn't real friendly to use. So using Microsoft's drag and drop thing to build your interfaces was better. So now somebody might say, oh, well, I'm going to use J++. So I can use Java syntax that I like because I'm the cool kid and I started using this new language. But I can use the tool to make my graphic user interfaces, which use something called MFC, Microsoft Foundation class. So all of a sudden now your Java programs are no longer platform independent because their GUI is written so it'll only work on Microsoft Windows. But who cares? 98% of the people are running Windows anyways. All right, so Microsoft came out with J++. Now, we mentioned earlier that Microsoft's kind of go-to move, as are most big companies. So again, I don't want to demonize Microsoft here. They'll steal something, and then if they get in trouble, they just settle outside of court, right? So let's say that you or I had made Java. And all of a sudden, Microsoft said, we're going to just use your language inside of our tool, and we're going to sell it. And let's say we're a little bit upset by that. We go to Microsoft and say, hey, stealing our language? Putting it into Visual Studio? I don't think so. They write us a check, and they hand it, and we walk away. $1 million? Okay. Sorry to bother you. That wasn't Sun Microsystems. Sun Microsystems wasn't just some kid. They were a multi-million dollar company. They fought Microsoft in court and won. So during the fight, so in the middle of this fight, they actually released a version of this called J Sharp. So this was kind of a, more of a branding thing. So they came out with something called J Sharp. So really what they do is they move the plus signs closer to each other. See how it works? So that's where the Sharp thing came from. More of a branding thing. So this is before they lost the lawsuit. So like at Visual Studio, the next version, maybe it was 7 or 6 point something, they had this language called J Sharp, which was just the newer version of that. Well, anyways, Sun sued Microsoft and won. So Microsoft had to dump J++/J Sharp. No longer included in their product. So they went back to the drawing board. And they created a language called C Sharp. C Sharp, actually, let me steal my Java slide from before. Just to get it in here. Oh, sorry. Wrong Java slide. Okay, well, we can use this one here. I think I already copied this. I just haven't written it yet. So let me drag this down a little bit. All right, right here. C Sharp, object-oriented language, still has variables, still has arrays, brought back structs. Remember we talked earlier that Java got rid of structs, then maybe wasn't quite well thought out. Has classes, reintroduced the special syntax for pointers, but only usable inside an unsafe code block. So basically C Sharp said, hey, we know that some of you miss being able to work directly with memory in Java. So we're going to let you work directly with memory in Java, but before we let you do that, you're going to have to kind of, prove to us that you are willing to take responsibility. So you can create an unsafe code block in your code, and only inside of that unsafe code block are you allowed to directly manipulate memory. So creating an unsafe code block is your way of saying, I know what I'm doing. So I'm just going to, right in this section, I'm going to do memory stuff. Trust me. And C Sharp allowed you to do that. Okay, so they kind of brought some of those things back. But at the end of the day, really acted a lot like Java. Okay. So in any case, Sun sued Microsoft, won. Microsoft went back to the drawing board, came out with what they claimed was a brand new language built from the ground up, never before seen, blah, blah, blah. I was at University of Illinois. I forget what year this was, maybe around 2000, something like that, 2001. This is before C Sharp had actually come out. And they had a ACM conference there where Microsoft was announcing this soon-to-come new programming language called C Sharp. And if you're ever at a conference that Microsoft is at, you always go to their events because they give out the best free stuff. You know, other vendors were giving out like yo-yos and bouncy balls and stuff like that. You know what Microsoft was giving out? Sealed boxes of Visual Studio 6.0 Professional. It was like $800 software. And all of us had already, stole it. So that went right on eBay. Right? Again, take the ethics class. Don't do that. Right? Yeah, so we'll sit through anything if they're going to give us free software like that. Yeah, the gifts they used to give were just great. I mean, that's how much money that company had. They didn't even care. Like, $800 software here. Let's take it. What a Buick, it's out. Let's give you a car. So in any case, I'm sitting there and I'm listening to this guy tell me about this brand new language that they're coming out with called C#. And he was just describing Java. I mean, what he described to me was Java. Everything that we knew about Java. Now, if we go back here and we look at our little chart that we've created, this new language C#, does it make sense for it to be similar to Java, which was similar to C++, which was similar to C? So at first glance, you might say, oh, well, they're just stealing Java. But the reality is, Java did a lot of stuff right. So if you're going to come out with a brand new language, you're probably going to use a lot of the stuff that came from Java. You just can't steal it directly. So they had to rename a couple things. So it becomes kind of interesting. Like if you wrote the Hello World program in C#, or you wrote it in Java, you wouldn't have to change very much to get them to work for the other language. Like a capital S to a lowercase s, and instead of system.out.println, it's console.writeline. Otherwise, they're identical. They say the same language. But regardless, I mean, that's fine because, even Java, you can say, looked like C++. Because they all came from C. They all came from the same place. So then, go ahead.
When asked about the C and C++ at the beginning, they launched by Microsoft?
No, they predated Microsoft. C was 1968. This is way before Microsoft. C++ was, I think, 81 or 82. I mean, Microsoft might have barely been a thing and jumped on that bandwagon with them, but they were not released by Microsoft. Microsoft had a language called Visual C++, which was their version of C++ that worked with Visual Studio for making GUIs and stuff. Okay, so then we get to here the comparison of C# versus Java. So Java, we already said, is platform independent, right? So if we draw a picture here, how these guys work. So for Java, actually I'm going to do it with text here. We have Java source code, which gets turned into Java byte code, which then, which actually goes through the Java compiler. Which turns into Java bytecode, which is then run on the JVM, which is then converted to the CPU natively. So that's how Java works. You have your Java program, you compile it, it turns it into Java bytecode, which then runs directly on that virtual machine we talked about earlier, which then converts it to the CPU. He kind of pointed out that this kind of makes it an EXE. So that's Java. So I'm going to... So we're going to say C# goes through the... Let's call it C# compiler for a moment, which turns it into missile code, which then runs on .NET, which then runs on the CPU. At a glance, these look pretty similar. They've just changed a couple of words, right? Instead of Java bytecode, we have something called missile code. This stands for Microsoft Intermediate Language. Pretty much the same thing. Java bytecode, missile code, they're both just intermediate languages. Bytecode is understood by JVM. Missile code is understood by the .NET component architecture. Both ultimately go from that interpreter thing to run on the CPU. Both go through a compiler. So what's the difference between these languages? Now, one of the things we talked about with Java is that it's platform independent. Write it once, it runs on any machine. Now, Microsoft says that C# is platform independent, just like Java. Now, Java's platform independent. It'll run on any platform that supports the Java virtual machine, right? So as long as the platform you're trying to run your Java program on has the Java virtual machine for it, Java will work. C# is platform independent as well. It will run on any platform that supports the .NET component architecture. Any platform at all, as long as it's Windows. It will literally run on any operating system as long as that operating system is Windows. So it technically is platform independent because it will run any platform that supports the .NET component architecture, which is only Windows. Only Windows supports the .NET component architecture. If Microsoft decided to write that for the Mac, which they're actually getting ready to do, then C# would run on the Mac.
You spoke about Xamarin first day of class. Xamarin runs C# and works on the Mac.
Yeah. There's actually a project that Xamarin is based on called Mono. And Mono is an open source version. It's called open source estimation of the .NET component architecture. Because the .NET component architecture is not available for Mac as a Microsoft product. So they've tried to figure out how it works and make something that's kind of compatible with it. And that's a project called Mono, which is an open source project. But Xamarin has actually been, and so Xamarin was originally based on Mono. Microsoft, I'm not positive Microsoft actually purchased Xamarin or has partnered with them. My guess is they have acquired them. Because Xamarin is now embedded in Visual Studio.
Yeah, they've acquired them already.
Yeah, so, well, right, I'm just trying to think how that relationship actually works. So that's even more evidence that Microsoft is porting .NET over to the Mac. There's also a version of Visual Studio for the Mac, but it's really a glorified editor. Yeah, it's a little bit whatever. All right, so this guy runs on any platform, supports the .NET component architecture, which means that it runs on anything that's Windows. Yeah.
Then how can we call that as platform independent?
Well, we can call it as platform independent just as much as Java can. It just so happens that Sun Microsystems wrote the Java virtual machine for more than one platform. But not for every platform. I'm sure there's some platform out there that the Sun Microsystem didn't port the Java virtual machine for. So you couldn't run a Java program on that one. It just so happens that Microsoft only ported their software to their own thing. But if they were to make the .NET component architecture, if they were to port that to Mac, a C# program would run on it. So it's platform independent in theory, but in practice, it'll only run on Windows. Does that make sense?
Till date, we can say it as platform dependent.
But the language is not. Yeah, so I mean, I think we're both basically saying the same thing. The language itself, because of the way C# is built, technically is no more platform dependent than Java is. It's only dependent on .NET, just as much as Java is dependent on the JVM. The difference is that the JVM is on multiple platforms, where .NET is not. But that's Microsoft's choice, not that they couldn't write it for the other one. So if Microsoft decides to port the .NET to architecture to multiple platforms, then C# would immediately become platform independent. So it's the exact same model, just it's almost the exact same model. There's one little thing that happens here. With C#, this is really their magic sauce, if you will. How many of you have ever seen a that acronym before? JIT. Yeah, just-in-time compiler. So JIT stands for just-in-time compiler. So what actually happens, if you have a C# program that you wrote, the very first time you run it, but only the very first time, it takes a little bit longer to launch. Because what happens is it runs through a just-in-time compiler that actually, and if you remember we talked about compilers, converts from a high-level language to a low-level language. It's converting from missile code, which is actually a low-level language, into native code for that CPU. So from that point forward, it's not running in a virtual machine. It's running natively on that processor. So you don't have the slowdown that you'd have from Java. The slowdown only happens the very first time you launch the program when it does that conversion for you. That make sense? So that makes C# technically higher performance than Java. But keep in mind that if Microsoft ports the .NET component architecture over to Mac, they would also have to write the just-in-time compiler that would convert the missile code into the native instructions for the CPU, which is going to be Intel-based instructions. But if you remember when we looked at Hello World in a low-level language, we used Linux system calls. So that same program for Mac would use Mac OS X system calls. The same program for Windows would use Windows system calls. So that just-in-time compiler would have to be ported as well to convert it to the Macintosh equivalent of Intel instructions. Make sense? Okay. All right, then to finish up, we have this language called Objective-C. We've already established today that Microsoft and Apple don't like each other. So when Microsoft jumped on the C++ bandwagon, Apple said, well, we're not jumping on the same wagon as them. So we're going to back another project called Objective-C. Both of these guys came from C. This was just a different take on the object-oriented version of C. Objective-C, object-oriented C. Okay? Still based on C, actually does look a little different. There's a lot of similarity it has with C, but it actually uses a syntax called message passing. And just to give you a quick idea there, for those of you who, well, actually, let me just... this isn't going to give you the best example. Let me just write one. All right, so if, well, I guess this is going to be okay. Let's say that I'm creating an object in Java or an object in C++. We'll do C++. So I'm going to create a random object. So random R is equal to new random. Okay, that line could be a Java line as well. Okay, Java is based on C++. So I'm creating a new variable named R of type random. I'm going to get some new memory, and this is the constructor for that guy. Don't worry too much about that right now because I have to introduce some Python stuff for you to know what most of those look like. So that's C++. That exact same line is Java. And I can't create that line for C because objects didn't exist in C. But now if I were to do the same line in Objective-C, it would look like this. Actually, let me... C++ would say random pointer there. So this is C++, this is Java, and this guy's going to be Objective-C. So I'm going to say random pointer R is equal to random alloc init. So this says allocate me some memory and then call the initializer for random. The new keyword, get you some memory, and here's the initializer for it. The same stuff is happening, but at a glance, you would say that because this uses a little bit different style syntax, it looks more foreign, right? It's using those square brackets and stuff. It's intimidating for a little bit when you first start writing Objective-C stuff, but then all of a sudden, you actually end up starting to like it. In fact, I would say Objective-C is one of my favorite languages. It's all the same. Programming is programming. You know, the same stuff is there in the different languages. Objective-C tends to be a little bit more verbose. You have more stuff you're writing, but then when you go to read it, it makes more sense. So don't worry too much beyond that, but that's the difference between the language. Other than that, we can say that Objective-C is kind of equivalent to C++. All right, kind of all the same complaints, all the same things existed as C++ exists in Objective-C. We'll call it a direct competitor here. All right, so now keep in mind that C++ and Objective-C came out around the same time. Now, until very recently, Objective-C was still the programming language of choice if you were a Macintosh developer. If you were writing software for iPhone, you used Objective-C. Up until about, you could still use it now, but probably up until about 3 years ago, you only used Objective-C. Because 3 years ago, Apple released our most modern language called Swift. How many of you have heard of Swift before? Okay, now, how many of you have ever met somebody that you would call like an Apple fanboy? Somebody's just really, really love Apple, and Apple can do no wrong. We've met those people. Okay, you walk into an Apple store, you're wondering where they're serving the Kool-Aid, right? So Apple people that are, you know, they never find fault in Apple, right? Do you think that these people here were bitching that they didn't like Objective-C? No, they loved Objective-C. It was great. Even to this day, I'm telling you, I like Objective-C better than pretty much all these languages. I don't program in it very often just because you got to use the right tool for the job, and Objective-C is kind of hard to teach with. But regardless, when Swift came out, it was not to make these people happy. These people were already happy. In fact, they were probably happier because not very many people knew how to program in Objective-C. It's weird enough looking that a lot of people are intimidated by it and wouldn't go and learn it. So they kind of like, you know what? I'm unique. And Apple people like being unique, right? It's a thing. It is kind of interesting that you have a Mac, but you use Android. Yeah, it's not right. I have 2 PCs in my office. Yeah. Oh, you got a PC at home too?
Yeah, I have a
Well, I got a good PC in my office. Old doesn't count. All right, so they came out with Swift. Let me go here real quick. Just gonna show you something. That's Swift. Does Swift look more like Objective-C or does it look more like Java? Here's my line in Swift. Here's my line in Java. Here's my line in Objective-C. It looks more like Java, right? In fact, all it's really done is it's taken out the new keyword. One of Swift's kind of tenets is, so if we kind of throw a slide in here for Swift. Reduce extra typing. for the programmer. So in situations where something would always be the same thing, they don't make you type it. So like if you are creating an object in any language, you're always generating new memory. This generates new memory, this generates new memory, this generates new memory. So with Swift, it just said, look, we know you're going to want to generate new memory in here, so don't type it. Just call the constructor. It's shorthand. So given the fact that Swift looks so similar to Java, I'm going to tell you another secret. You're not going to tell anybody, right? All right. These people were already writing iOS apps. They've been writing iPhone apps for years and years and years. They love Objective-C. They're not complaining about it. They're drinking the Kool-Aid. The best thing since sliced bread. They love it. Now, some of those guys actually maybe have been inconvenienced now. Early on, you could kind of choose whether you wanted Objective-C or Swift. You can still choose whether you want Objective-C or Swift, but the default choice is Swift. And most new libraries are written in Swift. So you pretty much have to use Swift now, or peer pressure puts you into using Swift now. But guess what? If you're an Android developer, you're using Java. Do you think? Now, first of all, I mean, you make more money selling apps on the App Store, iPhone App Store, than you do on Android. That's been proven multiple times. I mean, that more comes down to the quality of apps and also who the competition is. On Android, you have a whole bunch of like cheapy apps because on Android, you kind of have two different ways that apps are reviewed. So on Apple, you write an app and then it takes a week for them to review it to make sure it's like of good enough quality for them to put it up on the App Store. So they won't approve even a well-written app that makes like fart sounds or something. They won't approve that. But on Android, you could take a picture of yourself naked, upload it as an app, and until somebody complains, it'll be on the App Store. So there's no oversight. So which one of those is better? Now your gut feeling is you think I want you to say iOS's, right?
iOS.
Okay, that depends. On one hand, I mean, if I've released a whole bunch of iOS apps, I kind of want Apple to trust me. I'd like to be able to get an app up on the App Store pretty quickly. The bigger issue is with bug fixes. So on Android, let's assume that I release an app for Android. It's on the App Store instantly. And let's say somebody finds a major flaw in it. I can fix that bug and push the update right away. With Apple, I have to wait like 3 to 5 days for them to approve the update. They now have a system where you can like request an expedited review for like, a serious bug issue or something like that. But in those kind of situations, you kind of wish they had the Android model. So the truth is probably somewhere in between. Yeah.
But is that considered security for our user, for people who are using Apple?
Oh, I think so. I mean, not just security, but also kind of quality control. Apple only wants to let the best of the best apps on the App Store. So there are aspects of both models that make sense. So my argument would be maybe there should be some sort of licensing where like you have to apply for Apple. Maybe your first app or first 2 apps have to go through the processing thing. But then after that, you get like you're a certified Apple developer where they trust you that you will put quality stuff up that isn't going to have security flaws or something like that. That way you have the flexibility to release updates. Or maybe it's even just after the fact, where once they approve the app initially, then you can release updates instantaneously. But you're risking losing your license if you abuse that privilege. I think that would make some sense, but that's not what they do. So in any case, Swift is not to make these guys happy. Swift is saying, hey, Java people, come over to the dark side. Come write iPhone stuff with Swift because it looks like Java. Swift is saying, hey, web people, stop writing HTML5 based web apps. Come over and write native stuff for iPhone using a language that's going to look more familiar to you. Swift looks like Java. Swift looks like a lot of these languages over here. So Apple's little trick here is they were not upgrading Objective-C. they were luring in the enemy to write software for Apple stuff. All right, so that's really where Swift came from. And Swift has some ridiculous stuff in it. And they've kind of backed away from it now because when Swift first came out, it tried to be everything for everyone. So it tried to make itself look a lot like Java, but it also tried to make itself look a lot like Python and Ruby. So it had like 11 different ways of doing the same thing to kind of make life easier. They had dictionaries and stuff like that, just like Python has. But now they've moved back from that. They started saying, okay, well, I think we've lured in enough cattle, so we want to go ahead and let's have those people now, have to conform to the way Swift should be. The other thing I think Swift is ridiculous. They allow you to create variable names with emojis. Doesn't make any sense to me. Yeah, nobody uses it, but it's a thing. Okay.
What do you recommend?
What do I recommend?
Yeah, with all these.
I recommend using the right tool for the job. If you're writing an iPhone app, use Swift. If you're writing a Android app, use Java. If you're writing a video game, use C++. If you are writing a modern day web application, probably use Node.js. And with maybe Angular on the front end. If you are writing a web-only type of tool where you're just going to be a rapid application development tool for web, probably Ruby. If you're doing some data mining stuff, maybe Python. I would probably almost always pick something else over PHP, even though PHP is there's nothing wrong with it. I just think there's better choices now. But always the right tool for the job. One's not better or worse than another one. It's what's the right tool for the job. That make sense? All right, so. Sure.
There are many hybrid application developments like Mendix. So how many of you think like they use their Android Studio or the Swift types?
Yeah, so right now, kind of the popular thing you were mentioning, he was mentioning it earlier, Xamarin. So what he is referencing is like something called Xamarin, which is actually a Microsoft product now. So this is what's called a cross-platform tool for targeting. This targets iOS, Android, Windows Mobile, as well as BlackBerry.
You know, the
PhoneGap is it works a little differently, but PhoneGap is another one. So you got PhoneGap. You also have another one called AppCelerator. And each one works a little bit different way, but generally speaking, what you do is if you wanted to write an app that you were targeting for both, you were going to make the app for both iOS and Android. You might choose to use a tool like PhoneGap or like Xamarin and write the app once, and then that tool ports it automatically to the two platforms. But the weakness of that is you are very limited on how that app is going to look. You're having to use kind of a lowest common denominator tool set because you can't do anything with your app that is only in existence on one of those two platforms. So widgety apps, kind of calculators, that kind of stuff, certainly would be fine with something like Xamarin or PhoneGap. But if you're going to make an app that is like very specific, you're probably going to write those natively. If you're writing a video game, you're probably going to use a game engine like Unity or Unreal Engine or something like that, which can target both. So these guys have become pretty popular. But again, it goes down to right tool for the job. So Xamarin is not better or worse than Android or better or worse than Java or better or worse than Swift. It's if you're targeting both platforms and the type of app you're making is relatively simple, Xamarin might make a lot of sense. Something like that. Okay. So our homework is going to be your first programming assignment. So I'm going to have you read a little bit more in the book. There's plenty of programming examples in the book. So you're going to write a function in Python. that converts a number from decimal to any base. Write a function in Python that converts a number from any base to decimal. All right. So the hint here is this is going to be string concatenation to build up your answer. And so will the other guy. They're both going to deal with a lot of string concatenation. So now back in here, you've already read chapters 1 through 5. So first of all, these things are, I need to go down here, types. So string basics first introduces you to strings. List basics might come in handy as well. These are things you should have already read. String formatting, these are things that will benefit you here as well. Branching if statements, you'll need that. Loops, you're going to need repetition to keep whittling it down until you finally get something that divides by 0. Another hint I'll give you for Python 3. In Python 3, 5 divided by 2 will equal 2.5. 5 divide 2 will equal 2. 5 mod 2 will equal to 1. Does that make sense? In Python 2, this one would have given you the 2. But in Python 3, if you want to do integer division, you need to do the //. That'll be handy. Okay? So you've already read loops. So you're going to need to read chapter 6 for functions and chapter 7 for strings. Okay? Splitting and joining strings are going to be pretty handy. So what you're going to want to do is you're going to want to sit down and write an algorithm first. Step-by-step instructions for how do you convert a decimal number to any base. Step-by-step instructions for how do you convert from a base to a decimal number. And then convert those instructions into Python using the tools that have been introduced here. Okay? So the warning is you cannot, I'm sure the library exists, you cannot use any built-in library in Python for converting between bases. You have to do it logically yourself using loops and divisions and if statements and mapping a 13 to a D, that kind of stuff. All right? All the tools you'll need are going to be in chapters 1 through 7. This will be, you have a week to do it, but this will be tough because it's going to be your first kind of Python program you're writing. Make sure you've gone up here and you've run through some of these examples so that you can see how these things work. If you go to python.org, you can download Python natively on your computer. It's actually already installed on Macs. So if you're a Mac user, you can use Python on there, or you can download it directly on your computer. Otherwise, you can use the built-in thing for that's in your book. There's a Python interpreter that's in there. There's also a just do Python online. There's a online. Actually, that's not it. Actually, that was it. That'll do it too. There's a Python online editor. So there's all sorts of places you can go to write your code. Make sense? So this might be a good way. You write it up here, and then when you're done, you copy your code, paste it into the solution box for your homework. All right? Make sure you also give me your self-evaluation because this will be tough for a lot of you. So some of you might end up turning in code that is very broken or doesn't look like you did very much. So that's where that self-evaluation will have you explain to me, what your nightmare was like and what the things you tried are so I can give you partial credit based on your effort. Make sense? Questions, comments, concerns, bribes?
Coffee?
Well, what are you expecting for the coffee?
50% at least.
A 50%?
Just like to start
Aren't you going to earn a 50 anyways?
with.
You're going to work hard on this, right?
Of course.
Yeah, so I'll take a coffee and guarantee you 50% if you do the homework.
I do.
Go
I
ahead.
have a question. So you said from any base, so I'm assuming that the user gets to decide.
Yeah, the user. Well,
Or should we just keep it to binary?
Yeah.
Detection?
I don't care if you have the user decide the base from like reading it in from them. So, for instance, if you don't want to, you don't have to give them like a whole interactive system. You can say, what number would you like to enter? What what base you want to convert it to? They do input-output stuff at the beginning. I don't care if you do that. You can just have your program. You can hard code in there. I want to convert from base 2 to base 10, or I want to convert from base 3 to decimal to base 10. So it should do more than the default bases. It shouldn't just be binary, octal, decimal, hex. It should work for any of the legal bases through base 36. But you don't have to. The user doesn't have to. It doesn't have to be interactive, where you're asking the user what base do you want to convert to, and then they type it in and press enter, and then it does it. You don't have to make it work for them.
Just assume that it's going to be the legal.
You can assume it will be a legal base. So if they give you any base between base 2 and base 36, yours should work. If I give it a base of 53, your program can crash. You don't need to error check. So I want you to focus on the algorithm itself. Don't spend extra time error checking for weird inputs and stuff. You can assume that I will give your program legal input. All right, so make sure you test it on, bases between, if it works for base 2, 3, 7, 16, and 21, it'll work for any of them, right? Because we've already seen in here, the pattern is identical no matter which base we're converting between. Okay? I care most about the two functions. Okay, how you test them to make sure they're working, I don't care, because I'll test them myself. You should test them to make sure they're working, and you'll see how that works when you look at the functions section. But I'll be able to test it, but I'll be able to just look at it and see if it's working anyways. So if you want to do a whole user input system and stuff, which they've shown you in there, that's fine, if that makes you happy. If you just want to say, I'm going to test this base to this base and then test it, yeah, that works. Then you just change those numbers and test it with a different one, that's fine too. Sound good? All right, see everybody on Wednesday.